extent of the first time period, getting a two-dimensional data block, doing a two-dimensional Fourier transformation, and getting the image of a head. For example, of this one here. You know who that is? Read it here and look at me. It's my head. And people were astonished that there is also something in my head. And I was very much disappointed by that slide. Because the doctor in charge, he was coming to me, Professor Ernst, your slide looks completely normal, nothing special about you. Why did you get the Nobel Prize? So that's what I knew then. But I'm just a normal person. It's difficult to find out in science the brilliance, the intelligence, the creativity just by NMR. We are not yet as far as that. For example, this guy here, Carl Friedrich Gauss, a famous mathematician who died already 150 years ago, his brain was being preserved in alcohol and recently put into an MRI machine to find out just another brain. Nothing special about his brain either. So I'm at least in good company. This is not my brain, fortunately. With a brain tumor which you can display very beautifully by MRI. And for a surgeon it's important information. You can display here alcoholics. I know that you don't drink alcohol, certainly not extensively, because otherwise you would lose your brain. And see here, that's a normal female, that's a normal male, and these are alcoholics on this side. I mean, for a male, yeah, there is some brain shrinking here, there is some brain shrinking there and there, here a little bit, but it's not too bad. But if a female drinks too much alcohol, you see, she loses almost all brain matter. So I normally tell the charming ladies in the audience, if you get a bottle of wine, give it to your friend to empty, and you keep your brain for better things to do. And the only slide which you have to remember from my lecture is this one here. The small glass goes on this side and the big glass goes on that side. Please remember. Anyway, MRI is very useful. If you want to do brain research, if you want to explore a stroke which just have occurred, you see the blood vessels here very nicely. You see where one is leaking, and you can then do the proper measures. Now I'll show you my brain, part of my brain. That's me. And what you see here is what one calls a stenosis. A stenosis where the blood is not properly flowing through anymore. And the doctor in charge, he told me, Richard Ernst, that's serious. I mean, there will be once a moment when you will have a very easy death. The world will just disappear in front of your eyes, and you will be alone for the rest. That's what will happen. For me, it's easy. But for you, I mean, you can read it in the newspaper that there is one Nobel Laureate less, and you know, this could have been the reason for it. So I'm waiting for it. I'm anxious to experience it, but hopefully it doesn't happen so soon. Anyway, I had also other problems. For example, here, my legs. I have a right leg and I have a left leg. The right leg was always okay. The blood was flowing properly through to the foot down here, but the left leg, you see, no passage anymore to the foot. And the left foot was white, cold, and I had pains. I couldn't walk anymore, and I had to go to the hospital, and they did some surgery, and they put in a bypass. A bypass here, from here down to there, an artery stolen somewhere else, and put it in, and then it worked again. It worked again for a few months, and then the problem started again. So in last November, just about a year ago, you see it happened again. No blood flowing through here anymore. This time they didn't do any surgery, but they just went in with a balloon and opened the vessel again. And that worked. So maybe in 2 weeks I have to go again to the hospital. Maybe they will be doing the same again. So NMR is useful for prognosis of this kind of effect. NMR is also useful to check your brain when you have drunk too much alcohol, whether your brain is still functioning or not. Functional magnetic resonance imaging is very useful today. How can we sense the functioning of brain by NMR? Very simply. You know, your brain can only function when it gets oxygen. Oxygen is being transported by hemoglobin into the brain. And then the oxyhemoglobin is coming out without oxygen. And the oxyhemoglobin is paramagnetic. It acts on our NMR signal, and that's what we can detect. So we measure the dissipation of oxygen in the brain by NMR. That can be very useful. I just show you one simple example. The technique has been invented by Seiji Ogawa, and he is sitting in Tokyo and still waiting yearly for getting his Nobel Prize. He really deserves one. Tomorrow I will be in Tokyo, perhaps I will meet him. But anyway, he deserves really a Nobel Prize for this great discovery. But I'll speak about an experiment. Let us assume you and your friend, you are going to the hospital. And your friend, he is being tortured. They apply pain, he feels pain because it hurts so much what they are doing to him. And his brain is reacting like mad. They have put him into the machine, and you see here the brain reaction here due to pain. And you are standing nearby, and you feel so sorry for your friend. They don't do anything to you, but if they put you into the magnet, they find that your brain reacts at the same spots. So this is empathy, that's compassion. So you can do beautiful psychological experiments now which are reproducible. So psychology finally becomes a science. Psychologists don't like to hear that. That it wasn't a science before, but I mean, quantitative measurements, they are now possible with MRI, with functional MRI. That's a beautiful application of that. So I'm sure you agree that magnetic resonance imaging is an irrefutable testimonial to the enormous value of basic research. Now, you really can use it, it's really useful, and that I left my ivory tower in Zurich, went to California, that was really worth it. I mean, finally we achieved something which could be used for humanity. And that was, of course, a dream which I had, which I never thought that it would become true. So research is indeed for the benefit of society when you do it properly. Yeah, a few minutes. Or shall I end? You see, I have to tell you what happened in Asia. I didn't tell you that. No science anymore. No science, just art. So we decided to go back in '68 to Switzerland. We sent our children by airmail back to Switzerland. We went via Asia. You remember, we went to Kathmandu. We discovered the tankas. We bought this tanka here. And I started a collection. I started a large collection which I have now at home, and which fascinates me. Everything started with this big painting here. And many arrows are coming out here. The first arrow here, that's the fascination for Tibetan art. The second arrow is the Central Asian history, which is very complicated, very complex. Very much going on, and of course much is going back to India. And then Buddhist philosophy, which also originated here in India. I had to learn something in order to understand the here paintings. I had to learn painting technology and pigment analysis in order to maintain my collection, to do conservation and restoration of art. And finally,